So let's take a very simple example. So here I have two frames, and I'm telling you that the rotation of A to B is just about the z-axis. So the image on the right, I'm looking down on the z-axis. Now this should look very familiar to you when I ask you what is the rotation matrix. Why? Because you did this in algebra, right? You talked about just rotation of an angle theta about the origin when you were doing x, y. And hopefully you remember something that looked like this. See, it says cosine theta, minus sine theta, cosine theta, right? George Thomas, who wrote the calculus textbook that many of us use, taught it to me as Charlie's little sister, Sock Charlie. That way you remember where the minus sign goes. Anyway, so the point is that this matrix here is just for rotating the x and y, keeping the z constant. So if I wanted to get an arbitrary orientation, basically what I could do is a series of rotations to get things where I want them. Turns out there are many standards about how to do that. One that many of us know in math and computer vision are Euler angles. Euler angles say you rotate about z. If this was z, you'd rotate, let's pretend z is up. Rotate about z, rotate about the new x, and then you rotate about the new, again, z. All right? For those of you who fly airplanes, I think it's heading, pitch, and roll. Maybe it's boats. I don't know. Heading, you orient yourself. So, you know, northwest. You pitch, that's up and down this way. And then you roll, that's rotation about this way. All right? So you're about the world z, the new x, the new y. There's roll, pitch, and yaw. There's azimuth, elevation, and I guess roll for those of you who are used to launching mortars. Azimuth, anyway. Basically, there are these three basic matrices, rotation about the x, y, and z. The order matters. Okay? We're not going to worry too much, in fact, not at all, about getting that order. But what it is here are the three rotation matrices written as a function of their angles. There's the rotation about x, rotation about z, rotation about y. I put them in that order. Why? I have no idea. They used to be a different order, but it doesn't matter. The idea is that you can rotate about each of these different axes. Now, whether you pre-multiply or post-multiply, that's an issue. So do we do it the x1, then the y1, then the z1, or the z1, the y1, and the x1? And that depends upon whether you're rotating in the new frame or the old frame. Then, is theta positive or negative? So you have to worry about these things really well when you do this. And this is why we build spacecraft in simulation before we build them for real. Because when it doesn't work in simulation, the engineer says, I don't know, try -20. Because knowing which way your angles go is a very difficult thing.